Welcome to today's video. In today's video, we'll be drawing.
Thanks for watching the video and don't forget to subscribe, hit the notification bell, like, comment and share.
Uh, we'll be drawing a round wire spring of diameter 12 millimeters and has an internal diameter of 80 millimeters and a pitch of 50 millimeters. Can you guess what other information I need to add to this question? Can you guess? So we have the diameter of the wire spring, we have the internal diameter of the spring, and we have the pitch of 80 millimeters. Right? To see the three-dimensional effect of the spring, you have to draw at least two pitches. So we're gonna draw three pitches, all right? So draw three pitches. All right, good. For the spring, good. All right. Now, so in today's lesson, we'll be looking at the round wire spring. In the previous lesson, we looked at calculation of area for those who are doing CAPE. All right, so we're gonna start. Now, the first thing that you're gonna do is to draw the inside diameter of the round wire spring, right? Because the spring would be the cylinder that it fits on, okay, when they are making it, okay, or even after if they're finished making it. You know those press button pens, when you press a button, the pen retracts in and out. The spring, the diameter of the refill ink, the plastic container that holds the ink, the spring would fit on that pen cartridge, if you call it a kind of cartridge, is the right name, right? So the internal diameter for the spring would be the outside diameter for the pen pen cartridge, the thing that holds the ink. All right, good. So we're gonna start off with our cylinder. Is that okay with you? All right. So we're gonna go line. All right, gonna go line. And the diameter is 80. So we're gonna set out 80 here. Yes. Then we want three pitches, right? So each pitch is 50 millimeters, right? So 3 times 15 will be 150, isn't that so? All right, hope you're following. 150. All right. Then again, the diameter was 80. And then we're going up back 150 because we have three pitches. All right, good. All right. So now that we have established the cylinder that it's going to fit on, we need to now draw the plan. Yes? The plan would be, what shape would be the plan for the cylinder? Can you guess? Can you guess? It will be a circle, okay? So we're gonna draw a construction circle, okay? So I'm gonna draw a construction circle. Alright, so the diameter is 80, so the radius is 40, alright? What happened here? Yes. Right. All right, now the next thing you're gonna do, you're gonna add the the construction circle to represent the diameter of the spring, okay? So the diameter was 12 millimeters. Looking on the drawing, we're gonna change the diameter of the spring. Let us change it to 8 millimeters. Is that okay with you? I'm gonna change it to 8 millimeters. Right. So I'm gonna change it to 8 millimeters. Alright. Alright, so let's move this pan this over and come back to the drawing. Alright, so we're gonna draw it 8 millimeters. Alright, so we're gonna go line through the center. Enter. Alright. We're gonna draw a circle right here. And we said the diameter was 8, so the radius would be 4. Is that so? Alright, so the circle is 80, diameter 80, so the radius is 40. And what would be the radius of the center of the circle? The small circle representing the wire spring. If the diameter of the circle, this circle is 80, and the diameter for the small circle is 8, how far away would be the center of the small circle from the center of the large circle? I'm gonna pause a little bit and let you answer. All right, the answer would be 44 millimeters from the center. Isn't that correct? Yes? No? Maybe so? All right, we'll see. All right, so we're gonna draw a circle here, center, and the radius must be 44. So 44. All right. All right. Let's check it to see if it's correct. I'm gonna check if your answer was correct. All right. All right. So we're gonna draw the circle now, the construction circle to represent the wire spring. So the circle that I drew with radius 44 millimeters from the center, that would be a construction circle to give us the center of the circle. Okay, so we have located the center of the circle. So we're gonna go now circle, circle, right? And the radius, specify the radius, it would be 4 because the diameter is 8. All right, good. So we have our circle there. The next thing we're gonna do, we're going to cut up the outer circle into 12 equal parts, and you'll see what I mean. All right. Okay, here we have our circle in the plan, and we have divided the circle into 12 equal parts. The outer circle represents the center line for the circle of diameter 12 that represents the round wires that will be used to form the round wire spring. I've changed the diameter back to 12 millimeters so that when we're gonna draw the end of the round wire spring, I can show you a little bit better because the diameter will be larger, what the end of the spring would look like when you cut it, right? So assuming that the spring will be made from a long spring and then you cut it, the larger diameter, I would be able to show you a little bit clearer what the end of the spring would look like when it is cut. Okay, at the end of the video you'll see what I'm s- speaking about when I actually show you that part of the spring. Okay, so that is the reason for enlarging it, so that you can see it a little bit clearly. Okay, good. All right, so we have our outer circle, and as I said not too long ago, it represents the center line for the circle of diameter 12 millimeters. So what was the radius of the circle? Pause the video, and when you come back in another 30 seconds, I'll tell you my answer, and you can see whether your answer was close or a little bit off. All right, welcome back. So the diameter, remember the inside diameter of this circle, what was it again? 80 millimeters. So the radius is 40. Yes? I change the circle diameter for the small circle represent that will be used to represent the round wire spring to 12 millimeters. So we have 40 millimeters, half of 12 is 6, so the radius would have been 46 millimeters. And to get the diameter, if you wanted to get the diameter out, what would you do? I'm not gonna answer at this time. We're gonna move on with our video because the main purpose is to get our spring going. All right, and so let's go. All right, all right. Here's our circle. Right. And the next thing we're gonna do now, we're gonna project these lines to the front elevation using construction lines. Is that okay? Good. I hope you're following. Okay, good. All right. So we're gonna go line from each of these points, construction line. We're gonna go up, we're gonna go up, enter. All right. We're gonna repeat the same process again. So from the plan, we're gonna draw construction lines going towards the front elevation, right? So we're gonna plot these points. So there, 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 um, this point, going up, enter, go again, there, going up, enter, there, going up, enter, there, going up, enter. Good job. Did you get yours correctly drawn? Let me go up and see the top of mine. It looks a little bit, the last one looks a little bit tall, but we can correct that, right? Good. All right. So we have our construction lines going up. The next thing we're gonna do now, we're going to we're going to set off the pitch, the three pitches, so that we can plot the points. Is that okay? Good. Okay, we have set out our three pitches and I've measured the first one to you so that you could follow a little bit better, right? So if you wanted to see the question again, here's the question. Okay, good. All right. So the question is on the left, right? And we are constructing a round wire spring. All right, so let's zoom into the drawing. All right, the next step, we're gonna divide the pitch into 12 equal parts, okay? All right, so I'm gonna show you in a few minutes what we'll be doing. All right. All right. So what you're seeing on the screen is that I've divided the pitch, one pitch, into 12 equal parts, right? And it's also showing the plan with the construction circle for the 12 millimeter diameter wire, right? It's showing the center lines that are plotted going up towards the front elevation that are right. We're gonna plot the front elevation, the center line going around for the wire. So um let us do that now. Right here we have the circles going around to represent the wire going around, right? We're gonna also so we're gonna plot the points at the center line. You should have done this first, but it doesn't matter. The end result will be the same for this particular question, okay? Enter, all right? So there we have our center line going around. All right, so the next part, so we're looking for the point of tangency on the first circle. We're going to center the drawing so we can see all the circles. All right, so point of tangency at the first circle, second circle, third circle, fourth circle, fifth, sixth, seven, still at seven, going tangential, we're going to turn and go towards the right. 8, circle number 8, circle number 9. We're zooming in so we can see the point of tangency clearly. The next circle, next construction circle. I'm going to the next one, looking for the point of tangency. We're moving the drawing so that we can see the last two circles. All right, so here we're almost finished. We're on the second to last circle. And here now we're going to the last circle. Good. All right, and this would have completed our outer curve for our round wire spring. All right, so the curve looks smooth. We're going to close off the curve, end the curve, right at the point of tangency as shown on the screen. There it is. Good. So we have completed the outer curve. All right. We're going to center the drawing so that we can see the points clearly. All right. All right. We'll be finishing up the outer curve on the last circle for the first pitch. All right. So the curve is looking smooth. All right. We're just going to close off the outer edge for the round wire spring. All right, there's a curve. The curve has smoothed out, right? We're gonna center the drawing so we can see the all the construction. Good. So there we have completed the outer curve for the first pitch. All right. We're gonna plot the inner side for the spring. So tangential at the first circle, circle number 1, we're doing the inside curve. So we go circle 1 and 2. Zooming in so we can see our point of tangency. So circle number 1, 2, 3, circle number 3, 3, and 4, then 5, circle number 5. We're going to move the drawing towards the right so we can go up to the other circles. So we are at circle number 6 and 7. So going up to circle number 7. All right. Circle number 7. Yes. And we're going back now to circle 8. Circle number 8. Tangential, point of tangency. 8. See that circle number 8. Zooming out so we can see the other circle that we're going to, which is 9. Then we're moving on to circle 10. We're zooming out so that we can see the next circle. Zooming in so we can see the point of tangency. We want to move the drawing over to the left so we can see the next circle. All right, so there it is. All right, so we have picked up that point and moving to the next circle. And we are almost at the end of the last circle. Right there would be the end for the the inner line, inner curve for the round wire spring. Good. All right. So we're zooming out so we can see, check the drawing. Yes. And we have one pitch. It is complete. Right. There is our wire spring. Right. Now, what I have to do now is I have to correct the end. Right. Down here. All right. So we're going to All right, so we have selected the first pitch. What we're going to do, we're going to copy it to the other, where the other pitch location is. So we're going to come here, copy, copy, enter. All right, so what I need to do now, I want to get the circle that was down here. So I'm going to copy this circle. So let me fix the circle first, and then I'll copy the curve there. So all right, so we're drawing our circle, the same radius as now we're going to trim the excess because we just needed the arc. Are we going to zoom out? We're going to zoom out to see the effect of the curve. Are we going to fix a small little gap that was there, right there? Right, so we have zoomed into the drawing and we're going to close that gap, okay? All right, so there it is. All right, so I'm zooming out, zooming in to check. All right, there is a completed arc. We're gonna trim and remove the part of the circle that we don't need. The dark part for the circle was for the little gap that was there. We're gonna close this gap now. All right, this is aligned and good. All right, so we have fixed the corner now. All right, so we're gonna finish um completing the corner, which we didn't pick up in our copy. Enter. All right. Um, so we started there. All right, we're gonna see a circle here. Depending on how it is cut, we're gonna see a circle up there. Okay, we're gonna put a circle up there. Okay, so we're going to draw a circle here. Right, and this is all round wire spring. Yes. So the pitch is 70 millimeters, the diameter is 80, and the diameter of the rod is right. So we're gonna label it up. Is that circle? Copy, enter. Enter. Yeah, good. All right, so we're gonna label it now. All right, so we're gonna label the text. Label this wire diameter. This is wire diameter.
Thanks for watching the video and don't forget to subscribe, hit the notification bell, like, comment, and share.
So the question was to draw a round wire spring of diameter 12 millimeter that has an internal diameter of 80 millimeters and a pitch of 70 millimeter. So 70 millimeters, and we were required to draw 3 pitches for this spring. Here is the solution on the right. I hope that you were able to complete your drawing. Let me know your thoughts about the video. Thanks for watching, and in the next video, we'll be looking at loci. How does a mechanism move based on its given conditions, and we'll plot a point that is located on this mechanism. Bye.